In this video lecture, we will cover the topic from Module 1, Chapter 1. It is Introduction Part 2. After watching this video lecture, you will be able to recall the definitions of space and time. You will be able to differentiate between rigid body and deformable body and understand the concept of resultant force and equilibrium force. It is from this Chapter 1 of our GTU syllabus, Mechanics of Solid 213-0003. The first definition is space. It is a geometric region occupied by bodies whose positions are described by linear and angular measurements relative to a coordinate system. So here a coordinate system is there. What is space? Space is an unlimited expansion of physical dimensions in which all the objects are located. So any object in the space that can be located through this coordinate system, it is considered inside the space. So it is a linear measurement, linear coordinate system. There can be an angular coordinate system, but finally each and every object can be located through the coordinate system. So whole area, this unlimited expansion, is called space. The second definition is time. It is a measure of duration between two successive events. So the original unit of time is solar day. It is the time required for a single rotation of Earth on its axis with respect to the Sun. It is varying slightly throughout the year because of variation in Earth orbit and other factors. So solar day is not a constant, it is varying. So from the concept of solar day, we have derived the concept of second. Second is a fraction of 1 divided by 86,400 of an average solar day. So we have considered over here an average solar day, and this fraction of that day is called 1 second. Mechanics is a branch of science, and applied mechanics is the application of mechanics into engineering problems. It is further subdivided into mechanics of mechanics of rigid body, mechanics of deformable body, and fluid mechanics. So this topic, this chapter will be covered in the upcoming semester, fluid mechanics. Right now we will focus on mechanics of rigid body and mechanics of deformable bodies. So first let us differentiate the rigid body and deformable body. What is rigid body? In which relative distance between particles remains same after application of force. So when the force is applied, the shape is not changing. We are applying a rotational force over here to this gear in the center. So that gear is transferring the motion. It is not changing its shape because it is a rigid body. Same way in deformable body, the shape changes under application of external force. Here is an example of cantilever beam is given and the force is applied at the end. Because of this force, the body is deforming, the shape is deforming because it is a deformable body. There are many examples of deformations given over here. Again, for the case of cantilever beam, here the force is there in horizontal direction, so deformation is there in horizontal direction. Over here it is in vertical directions. But one point is to be noted, that practically each and every body in this space is deformable. So every body is deformable to smaller or greater extent. The next concept is resultant force. An object may have several different forces acting on it. So here is an object, there are 4 number of forces acting on it, which can have different characteristics. They may have different magnitude, different directions, and different point of applications. But all of them can be added together to give a resultant force. So what is resultant force? Resultant force is a single force that has the same effect of the object on the object as all the individual forces acting together. So all the forces are causing the same effect as the resultant force acts. So in this example, 3 forces are acting on the forward direction. So resultant of it will be there in this forward direction. Here one force is in forward and second force is in backward. So resultant will be there in forward direction because magnitude is higher for F1 and lower for F2. In this example, a steamer is being carried by 2 small boats. So 2 forces are acting in this direction and this direction, but finally the boat will travel in forward direction. Why? Because resultant of this 2 is in forward direction. The concept of equilibrium, it is a situation where net force acting on the object is 0. So whenever there is no resultant force, there will be a no motion, and it is called a balanced force condition. So all the forces are balanced by any other force. What is balanced and unbalanced force? In the first example, let us say this is a boy. He is being pushed by two brothers. Let's say his Chagan and his Magan. They both are twins and both have same power. So both are pushing him in opposite directions. So in that case, the body will be there in equilibrium because resultant force is 0. F1 force and F2 force both have same magnitude but in opposite direction. So the resultant force is 0. It is called a balanced condition. In the second case, now both the brothers are pushing him from one end. So what is happening? The resultant force will be there in this direction. So body is not in equilibrium, body is unbalanced, and the resultant force will be there. R is equal to F1 plus F2. Now if we want to make the body in equilibrium, what we can do? What is the resultant force? R is equal to F1 plus F2. So we can apply a same magnitude of force but in opposite direction. Let's say one force is being applied in this direction having magnitude F1 plus F2, then the body will be balanced. It will come in equilibrium because what we have done, we have applied a force having same magnitude of resultant force but in opposite direction. So to make the unbalanced condition into a balanced condition, we need to apply a force that is called equilibriant force. In order to balance the unbalanced body, we need to apply a force having same magnitude and opposite direction of the resultant force. So F1 and F2 force are there. The resultant of will be there in this direction. This will be in body will be there in unbalanced condition. To make it in the balanced condition, we'll apply another force in the opposite direction having the same magnitude of resultant force. The reflection quiz for this video lecture is: write down the definitions of resultant and equilibrium force in your own words and find out 5 examples of equilibrium condition from your day-to-day life. Thank you.